what we've got here is we've got 1, 2, 3, 4 lines, and we can notice that these lines are all going in different directions and that they are at different levels of steepness. And in maths we can actually calculate the gradient of these lines, which is a measure of their steepness. Generally, when we're in a situation like this, if we were given a coordinate system, to calculate the gradient, which we call m, we look at the vertical height over the horizontal distance. And what I mean by that is, like, we could construct triangles, and we can generally count boxes. So say, for example, if this was 7 boxes and this was 3 boxes, the gradient would be 7 over 3. Few things to spot here though, because we're going to expand upon this m equals v over h. We're going to expand upon it to give us things that work within a more generalised situation. But see here, we've got lines that are sloping upwards from left to right. When we've got lines that are sloping upwards, that means the gradient is positive. If we've got a line that's sloping downwards from left to right, that means that the gradient is negative. Okay, before we start with talking about the gradient formula, there's just a wee thing we need to recap on. When we think about plotting coordinates, coordinates are always in the form your x coordinate, then your y coordinate. You always go along x, you move along your horizontal axis, and then you move up and down. So just generally keep that in mind, your x coordinate, then your y coordinate. What we're going to be using in this video is the gradient formula. And the gradient formula is given by y2 take away y1 over x2 take away x1. We're going to discuss where we get these values from, and we're going to put it into practice with a few examples. Okay, here I could be asked a question to calculate the gradient of the line joining the points A and B. And if we think back to our gradient formula, the gradient formula was m equals y2 take away y1 over x2 take away x1. And just if we recall at the side, on the first slide we saw that the gradient formula is given by m equals v over h. So if we were given two coordinates, a and b, or two sets of coordinates, the y represents the vertical. So if we find the difference of the y's, we can find out what the vertical change is, and if we find the difference of the x's, we can find out what the horizontal distance is. But where are we going to get these values from? If we think back to just a generalised coordinate system, it's always in the form x, y. So here we've got two sets of coordinates, so I'm going to label the first one my first x coordinate, my first y coordinate, then my second x coordinate and my second y coordinate. Okay, just remember that it's always x, then y. So what we've got now is we've got our terms. We're just going to put this into our equation, put these values into our formula. So y2 is 9, so we're doing 9 take away y1, which is 2, and then x2 is 7 take away 1. And then I'm going to simplify, I'm going to have 7/6. So the gradient of this line is 7/6. If it's improper, leave it as improper, don't change it to a mixed number. However, if this fraction can be simplified, simplify it. Never convert your answer to a decimal. Okay, here we've been asked to calculate the gradient of the line CD. So first thing you do is you need to write down your gradient formula. M equals y2 take away y1 over x2 take away x1. Difference of the y values and the difference of the x values. So we need to label our points, our first x coordinate, our first y coordinate, second x coordinate, second y coordinate. We're now going to substitute these values into our equation, into our formula. So it's going to be 0 take away 3 over minus 4 subtract 0. And my gradient is going to be minus 3 over minus 4. I said in the last slide to simplify your fraction if you can. And normally if we saw 3/4, we would say that we can't simplify that. But if we recall back to our number properties, that if we've got a negative number divided by a negative number, we get a positive answer. So essentially here, when we've got negative 3 over negative 4, we can actually divide both by -1. I'm just going to put this over the side, so -3 over -4 can simplify to 3/4. Okay, here we've been asked to calculate the gradient of the line joining EF. There's a few more negatives involved, but we still just approach it exactly the same. We don't change the process, we just need to be careful with our integers. So step 1, you write down your formula. y2 take away y1 over x2 take away x1. We label our points, my first x coordinate, my first y coordinate, my second x coordinate, my second y coordinate. And we're going to substitute these values into our equation now. y2 is -6. Then I'm taking away y1. y1 is -3. So write out what you're substituting in full. Don't try and take a shortcut and do it in too few lines. Take your time with the working. And then x2 is 2, taking away x1, so taking away -4. And if we can recall our integer properties, when we are subtracting a negative, that's just the same as adding. And same at the bottom, I'm subtracting -4, so that's the same as adding 4. Generally your working should still go down the way, but I don't have room, so I'm going to do it over here. -6 plus 3 is -3. 2 plus 4 is 6. Always remember to check if our fraction can be simplified. Both can be divided by 3. We'll get the gradient as -1/2, which would correspond to a line that would go in a downwards direction. Thanks very much.